So in this section, we're looking at a specific type of sequence called an arithmetic sequence. And in an arithmetic sequence, each term differs by the same number, and that's called the common difference. So notice, so you got a sub 1 here, then the next term is a sub 1 plus d, and then the next term is a sub 1, sorry that's a typo, plus 2d, a sub 1 plus 3d, or what I probably was starting to type here was a sub 2 plus d, and this is a sub 3 plus d. So you just keep adding d to the term before, or you can define that recursively or write it recursively. The term before is a sub n if you're on the n plus first term, so a sub n plus d. One thing I should point out, d can be positive or negative. So you're not restricted to a positive difference here. So again, d is called the common difference. The nth term, if you notice in this formula here, a sub 1 plus d, a sub 1 plus 2d is the third term, a sub 1 plus 3d is the fourth term. So the nth term is a sub 1 plus n minus 1 times d. So if you're talking about n being 1, n minus 1 is 0, that's just your first term. N is 2, then you're just adding d. N is 3, then you're adding d twice, etc. Alright, so the key is when you read the problem, you have to notice the word arithmetic, especially in a problem like this one, as we'll see. This one is pretty explicit because you're given d. It says d is 4. So a sub 1 is 2, d is 4. Find the first 4 terms. This is super easy. a1 is 2, a2 is 6, just 2 plus 4. A sub 3 is 10. Just keep adding 4. A sub 4 is 14, etc. And then it says find the 50th term. A sub 50, so you use this formula, is a sub 1 plus 50 minus 1 times the difference is 4. I don't know why I wrote a sub 1 here. I should just put 2. 2 plus 49 times 4. So 198. Alright, so in this example, so you're only given 2 terms. The key to getting, there's no pattern for you to like figure out the next term. Like sometimes you see a pattern, right? Like if it was 2, 4, 6, 8, etc. You could figure out the next term. There's not enough here to get a pattern, but the key is to notice it says arithmetic. So that tells you you can find d. If you know it's arithmetic, there's 9 in between 15 and 6. And we're going down, so d will be a negative. So, whoops, I said 9 and I wrote 7. D is negative 9. That's why I should always use a pencil. Okay, so a sub 1 is 15 is given. A sub 2 is 6 is given. We're supposed to find the first 5 terms. So we just keep subtracting 9, excuse me. So 6 minus 9 is negative 3. Negative 3 minus 9 is negative 12. Negative 12 minus 9 is negative 21, etc. Now we want the 200th term, a sub 200. So start with the first term, which was 15, and add n minus 1, which is 199, and then times the difference, which is negative 9. I'll get my calculator out for that one. So we've got 15 will be minus 9 times 199. Is negative 1,776. Okay, so super easy. Just a real simple formula. So that, you know, it's just remembering the formula basically. All right, in the next example, again, we're told that sequence is arithmetic. This time we're given a sub 11 is 52 and a sub 19 is 92. We want to find the 1000th term. Obviously we don't want to count up to 1000, right? So again, the key here is understanding this is arithmetic. So we could basically find the difference between a sub 19 and a sub 11, which is 92 minus 52 is 40. And then, since there's 40 between the two terms, we just need to divide that up by how many terms there are. And 19 minus 11 is 8. So we would just divide that by 2 or by 8. So the difference will be the difference in the terms, 40 divided by 8. You would add that 8 times, right? And so D is 5. Therefore, a sub 1000 will be a sub 1, which isn't given, right? So you could figure it out. I guess I should have figured it out here. You can figure it out using the formula. You would take 52 minus difference is 5, and there'd be, that's 10 terms away, so 10 times 5 is 2. Or you could just start with, you know, the 11th term or the 19th term and then add or multiply by enough to get you up to the 1000th term. But I'm going to use a sub 1 plus 999 times 5, which is, like we said, 2 plus, what's 999 times 5, well, 4,095, yeah, 4,995, so 4,997. Right, so we need this, you need to find this D first of all. So difference in the terms divided by the difference in the number of terms will give you D. All right, the next example, we want to find the sum of k equals 1 to 100 of k. So we're basically adding up 1 plus 2 plus 3 plus 4, etc. I mentioned this in the last lecture that we would talk about adding up the first n integers, positive integers I should say, and that's what we're doing right now. So in this problem, here's the setup. We don't actually want, we want to come up with a formula, okay? It wouldn't be that hard to add up the numbers, right? There's only 100 of them. But, well, you know, what if I ask you to add up the first 5,000 integers, right? It gets to be a pain. So we can write a formula for this is what we want to do here. And so the idea is if we list the numbers, right, we're going to add 1, 2, 3, 4, 5, 6, etc. And then say we go down to half, so half of the numbers would be 50, and then I'm going to start going up. So this number would be 100, 99, 98, 97, etc. And so instead of adding up like this, I'm going to add 1 plus 100, and then 2 plus 99, etc. So we're adding the rows instead of the columns. So notice that each of these sums is 101, and that's what's going to make our work easier. So if we were doing 1 to 1000, we would just do this 1 plus 1000, 2 plus 999, etc. We'd get 1001, of course, instead of 101. But that's a constant, and we know how many of them we have. So how many do we have, right? This keeps going. Well, we have 50, right? And so the sum of k equals 1 to 100 of k would be 50 times 101, which is 5,050. So can we come up with a formula, right? We did it for n equals 100. Well, the formula then for the sum of the first integers the first, excuse me, positive integers, I should say, which can also refer to as the natural numbers. K equals 1 k equals 1 to n of k is equal to, so notice this top number, this 101 is the top number plus 1, right? I talked about that being 1,000, and then it would be 1,001. If it's 10,000, it'll be 10,001. So this part is n plus 1, and this part is this number divided by 2, because you'd be cutting the total, you know, whatever this number is, you'd have half here and half here. So n over 2 times n plus 1. Now if you went back and did that problem in the other section, which I don't have those notes handy, but and change that back to 50, now you'd be able to do that problem pretty easily. Okay? So why did we look at that here? Well, that's going to make this, we're going to use the same basic technique. Like, that problem's pretty easy to understand and understand why that formula works. We're going to use that same basic technique now to find the sum of the first n terms of an arithmetic sequence. So the formula for the nth term of an arithmetic sequence is a sub 1 plus n minus 1 times the common difference, right? We already talked about that formula. So if this is a sub n here, right? K equals 1 to n. So this would be the first term, the second term, the third term, fourth term, etc. And this is the nth term. So we want to add those all up. Well, the idea is basically the same as what we just did. We're going to take the first and the last term, and then the second and the second to the last term, just like we did right here, right? It was first, last, second, second to the last, etc. So to find the nth partial sum, we'll take a sub 1 plus a sub 1 plus n minus 1 times d. And then we'll take the second term, a sub 1 plus d, plus the second to the last term will be a sub 1 plus, this will be n minus 2 times d. You got to reduce, you'd be adding 1 less of the common difference, right, to get the term before. And now this will be a sub 1 plus 2d plus, this will be a sub 1 plus n minus 3 times d, etc. Keep going. And how many of these are there going to be? Well, if there's n terms here, then there's going to be n over 2 terms. And then notice each sum, right, we're again adding up the rows, not the columns. These are like terms, 2a sub 1 plus n minus 1 d. Notice a sub 1 is there twice again in the next row. And then, because this is n minus 1d, but here's an extra d, that bumps it up. There's actually n minus 1 d there. Again, a sub 1 plus a sub 1 is 2a sub 1 plus, well, n minus 3, but then add 2 more, there's actually n minus 1d. Every row will have the same sum. There's n minus 2 of them. So the sum is n over 2 times 2a, these numbers. There's 2a sub 1 plus n minus 1d. And we denote this, I mentioned it here, but I didn't talk about it. This is the nth partial sum of the arithmetic sequence. It's denoted as sub n. Well, I won't write it again because it's right here. Right, that equals, I'll just say it equals s sub n. So this is the formula we derived. Another way to write that then is here. Okay, we get n over 2, the a sub 1 plus a sub 1 plus n minus 1 d. This is a sub n. So you can just add up the first term and the last term, exactly like what we did in the previous problem, right? We added, or in the previous formula we derived, right? We added, the first number is 1, the last number is 100. Add those up and then multiply times n over 2. There would be, of those, that total, there would be half. That would happen n over 2 times. Alright, so let's use the formula to, in this first example, it says find the sum of the first 40 terms of the arithmetic sequence. So we know the first term, we need to know the last term, and then we can find the sum. Alright, well, to find the last term we need d. What's d? Well, notice that we keep adding 4. So d equals 4, and then a sub 40 will be 3 plus n minus 1 is 39 times 4. Let's see. 3 plus 39 times 4 is 159. So s sub n, I should say s sub 40, the 40th partial sum. So you're adding the first 40 terms would be 40 over 2 times a sub 1 is 3, a sub 40 is 159. Okay, so that's a sub 1, that's a sub 40, and of course that's n, right? So 159 plus 3, and of course that's 20, so times 20, 3,240 is the answer for that one. Alright, the next example, we want the sum of the first 50 odd numbers instead of the first 50, no, well, I should say integers, right? Well, of course, other numbers aren't even or odd. It has to be an integer, but let's just be more descriptive, positive integers. Alright, so the first 50 positive integers, right, we'd have 1, 3, 5, 7. This is what we mean. Note this is an arithmetic sequence. And what's the difference? The common difference is 2, right? You keep adding 2 to the previous number. So a sub 1 equals 1. What's a sub 50? Right, we need the 50th term. Well, that would be 1 plus 49 times 2, which is 99, of course. So the 50th partial sum would be n is 50 over 2 times, the first term is 1, the last term is 99. Of course, that's 100. 100 times 25 is 2,500. Right. Alright, one more example. Here's another place we could use something like this. It says an amphitheater has 35 rows with 20 seats in the first row, 23 seats in the second row, 26 in the third, etc. Find the total number of seats. Because of the pattern of we keep adding 3 to each row, this is really an arithmetic sequence, right? We've got 20, 23, 26, etc. So that's arithmetic with d equals 3. And of course, the first term is 20. A sub 1 equals 20. There's 35 rows. This is the first row. The 35th row, we would take 20 plus 34 times d is 3. Right, so this is n minus 1. Let's see, what do we get? 20 plus 34 times 3 is 122. So S sub 35, right? The sum of the first 35 terms, or number of seats in the first 35 rows. 35 over 2 times first term plus last term, 20 plus 122. I should mention, I tend to like find the last number using the formula we already know and add up the two terms. But you could certainly embed this in the other version of the formula. You're just embedding, well, this into here, right? I just do it out here and then put the answer in. That's up to you. Let's see, where did I put that? Oh, it's on the back of this sheet. No wonder I can't find it. Right here, that's what I'm talking about. Right? The 2a sub 1 is just separating out. So I'm just doing this out here, adding a sub 1, a sub n. But you can certainly use this formula if you want. That's just the way I like to do it. All right, so 142 divided by 2 times 35. So we got 2,485 seats in the amphitheater. All right, so that's it for arithmetic sequences. In the next section, we'll talk about geometric sequences.